Okay, so today what we're going to do is we are going to distribute polynomials to transform expressions into standard form. Standard form, we remember, is sometimes called general form. So we're looking for standard form of a polynomial. We want to be able to distribute a constant to a polynomial, distribute two binomials, and distribute higher degree polynomials. To preface this, we're going to start out by a little background work where we already should have been comfortable, but just to clarify. So, if I'm given something, a set of directions that says write the expression in standard form, I need to make sure that I have one of my three, or well, right now we're looking at linear, quadratic, and cubic standard form, but you can easily have something bigger, and once you see the pattern, it actually becomes really easy to do. Let's say we're given something like 7x minus 5 minus 2x. Well, this expression is not in standard form because we know standard form is going to be, if it's linear, y equals ax plus b, quadratic, y equals ax squared plus bx plus c, and so on and so forth. Where we never have two like terms that are not combined. So in this case, I'm simply going to combine these two terms, and you should be pretty comfortable with this. So you're going to do 7, make sure you keep the sign, minus 2x, or minus 2, so that you end up with 7x minus 2x, which is 5x, and minus 5. Now I have all my x's first, my numbers second, and if I wanted to go a little bit further, because this is in standard form, I could call this linear, because the highest exponent is a 1, and a binomial, because there are two terms. So that's kind of the simple form of it. Let's stick with the same instructions, write the following expression in standard form, and what we're going to look at now is something where a lot of students will make a mistake. 2x plus 5 minus 4x minus 7. If I'm given something like this, the tendency for students is to say, I want to FOIL this. 2x times 4x, 2x times negative 7, and they're using that method, that little cheat of distribution called FOIL. But this is not multiplication. Since it's subtraction, what you're going to do is you're going to pretend that this is negative 1. And instead of distributing this, you're going to distribute this negative 1. So that on your next line, you end up with 2x plus 5, negative 1 times positive 4 is minus 4, and then your x, minus 4x. Negative 1 times negative 7 is positive 7. And in this case, I've got a couple different like terms. I've got my x's, but I also have my constants. Both of those are constants. So I need to combine both. 5 plus 7 is going to give me my plus 12. And 2x minus 4x is negative 2x. This is in standard form, where a equals negative 2 and b equals 12. We also know that this, again, is a linear binomial. It is possible to have a linear monomial. That would occur if you ended up with just, say, negative 2x, and there was no 12 here. Alright, so next type of example would be if you do have a binomial, and I'm going to put 2x squared plus 7 times x minus 1. In this case, we do kind of want to go back to our former almost like that FOIL idea, I like to use the word distribution in my class because that's a rule that will always work. So if I distribute the 2x squared, I'm going to go 2x squared times x. That's going to give me 2x cubed, because this is like a 1, and when we multiply the same base, we add the exponents. That's this 2 plus this 1. Next, I'm going to go 2x squared minus 1 times minus 1. Anything times 1 is just itself. When there's a minus, it just switches the sign, so that we get negative 2x squared. Now, I'm going to take my second piece, the 7, multiply it times x to get plus 7x. And then multiply it by negative 1 to get negative 7. Now in this case, because I had two different degree terms right here, I ended up with 4 distinctly different terms. So there's nothing to combine, there's no like terms. Remember, if the exponents are not the same, you cannot combine them. This becomes my standard form of this expression. To identify here A, B, C, and D, I'm going to come through and I'm going to say, well, A is 2. That's that 2. B is this. Always keep the sign. So negative 2. C is 7. And D is negative 7. It just so happened that we ended up with all 2's and 7's here. That does not have to happen. The reason that happened is because we had both 1's here and different degree x terms. Alright, if I wanted to name this, it's got a 3 as the highest exponent, so it is a cubic. The name by degree is cubic. There are 4 terms. Whenever there are more than 3 terms, we just call it a poly, meaning many, nomial, meaning terms. Many terms. And so now we've seen a multiplication with just 2 binomials. One quadratic binomial times one linear binomial gave us a cubic polynomial in this case. So let's check out what happens when we have a binomial, x minus 9, times a trinomial, x squared plus 5x plus 1. What I'm going to do here is the same distribution, where I go 1, 2, 3, and watch what I do. I'm going to say x times x squared is x cubed. That's this arc. X times 5x is plus 5x squared. X times 1 is x. Now at this point what I want to do is I want to come through and I want to do my second piece. I'm going to do this in red. Negative 9 times x squared is negative 9x squared. Negative 9 times 5x is 45x. And negative 9 times 1 is minus 9. The reason I write it like this is not because it has to be, but it saves me from having to do the underlining of like terms or the boxing of like terms, anything like that. Now I simply just have to add down, so that I get x cubed. Negative 5 minus 9 is negative 4x squared. X plus 45x's is 46x, and then minus 9. This is a cubic polynomial, and I can identify A, B, C, and D. A is 1, B is negative 4, C is 46, and D is negative 9. That's how you put things into standard form and use distribution to help you do it. Combine like terms. And I even added in the naming of the particular polynomial.